point slope form, just recall the m was still your slope, and then this is the x coordinate of the point, this is the y coordinate of whatever point you were given. All right, so a quick little review here. If I gave you, given a line with a slope of 1/2 passing through this point, write the equation of the line in point slope and in slope intercept form. Since the two things you are given right now is a point and a slope, that's the one that you would want to start with. That's the form we would want to start with. So I have it at the top, but I'll still, since it's our first one, just rewrite the original looking formula for point slope. All right, so that's what point slope looks like in general. The m is our slope. You were given that. The slope is 1/2, so you're going to slot your 1/2 right there. And then we do x minus our x coordinate. So this little x sub 1 just means go to your point, find the x coordinate, and the x coordinate there is a 4. So we do x minus a 4. And then this y sub 1 means you go to your point. In this case, your y coordinate at that point is a 3, so you slot the 3 in, and then that's your slope or point slope form. If I just ask you to write point slope form, that's your answer. That would be a legitimate answer. You don't have to simplify. You don't have to do anything with it. Now, I am asking you to also put it into slope intercept form. So if you recall, all we did with that is we then took this and then simplified it a little bit. So you took your 1/2 and distribute. So 1/2 times x would be 1/2 x. The 1/2 times your 4 would be a 2. And then we still add the 3 at the end. So in slope intercept form, you would have a 1/2 x, the -2 and a +3 make a +1. So here's our slope intercept form. This would be our point slope form. Okay, so those would be our two different answers. All right. All right, number 2. In this case, since I'm asking you to do both, point slope and slope intercept form, but in this case, we can look and we know what our y-intercept is. So slope intercept form, you could actually do this form right away. This is probably what we're most familiar with, what you've done the most of in your lives. Because we can look at this and right away know if my y-intercept is a 3, then we know we're going to have y equals mx plus a 3. And the only thing we would now need to calculate using our line is the slope. So we just want to figure out what is the slope of that line. I have a couple of points marked nicely for us to count. So if I'm going to go from this point to this point, I go up 1, up 2, up 3. And then I've got to go left 1, 2. Uh-oh. So that's +3, -2. That's our slope. So -3/2 is our slope. Y-intercept is 3. That's our slope intercept version. Now, point slope, we can get some different looking stuff here. And that's okay. And it would just make Mr. Kubowitz's and I's job a little bit more involved, because if I want you to now put this in the point slope form, so here's the general formula. Come on. The slope doesn't change, so that's still going to be that -3/2. But when I now ask you for a point on that line, there's a few points on that line. I have 2 of them marked, so we could use this point. You could use this point. We also have this point down here. So we really have 3 different points we could use to write the equation of this line. All right. So Ella, what point do you want to use, Ella? Doesn't matter. All right. So she said 2. So if I'm going to use this point, that's the point 2. I can get it to work. 2, 0. So if that's my point, I'm going to do x minus the x coordinate. This just means take the x coordinate of this point. That x coordinate is a 2. And then plus, and then this means find the y coordinate of that point. The y coordinate is a 0. Don't necessarily have to write the 0, but that would be our answer. Okay? Or, just to make sure we understand, let's say we would have picked point 3 down here. Point 3 has the coordinates of 4, -3. So we could have done a slope of a negative 3/2, do x minus a 4, since that's the x coordinate of this point. And then the y coordinate of this point is this negative 3 right here. So we would do a minus a 3. All right. Now keep in mind, and I'm not asking you to do it right now, but I promise you, if we were to simplify this, and if we were to simplify this, both of these would simplify to give you the same exact slope formula. They end up all looking the same if we go through those steps, okay, if we do it correctly. All right. Okay. Let's do one of these guys. We'll make sure we get to the next page. So write the equation of a line that passes through these 2 points, and then describe the line. You're gonna do it's the same thing in number 4. Actually, maybe we do both. So in order to do this, no matter which form we were to pick, whether I do slope-intercept form or point-slope form, the thing that you always have to write the equation of a line is our slope. Both of them require us to know the slope of our line. You're not given the slope. In the previous problems, I gave you the slope, or we looked at the line and we counted out the slope. What we're given now here are 2 points. So this requires us to recall the slope formula. So the slope formula is this, the difference in our y values divided by the difference in our x values. That's how we find our slope given 2 points. So as we go through this, let me go ahead and plug in now. The y coordinate in the second point would be that negative 3. So you're going to slot in a negative 3 there. So let me get rid of this. This would become our negative 3. Minus, and then we want the y coordinate in the first point. That's going to be the 5. So we're going to slot in the 5 right there. Then we do the same thing with our x's. This means the x coordinate in point number 2. The x coordinate in point number 2 is a 2. So you're going to plug in a 2 right there. Oops. And the last one, we want the x coordinate in point number 1, which is also a 2. So we should get a negative 8 on top, 0 in our denominator. So make sure we get that. Let's see how quickly my calculator can open in the new semester. Because now what we should have, anybody remember what this gives us when I do negative 8 divided by a 0? And don't say 0, right, Cam? Brave souls, nobody remember? Let's see if this guy's open. All right, let's see what our calculator tells us. What do you think, Cam?
Positive 8.
Nope. All right, Mike, you tried, and I give you credit for that, Cam. I appreciate it. On our early Monday morning. All right, let's see what the calculator tells us, because the calculator would never be wrong. So let's clear that out. Let's do a negative 8 divided by 0. All right, remember how we talked about you cannot divide by a 0? Is this what yours says, Cam? Negative 8 divided by 0? That's a problem. We cannot divide by 0. So what that means, and you would have talked about this at some point, you do it a little bit in Math 1, probably did it as an 8th grader when you learned slopes for the first time. This is when we say that our slope is undefined. All right. Now, what's tricky about this is we cannot go to these here, and we want to be plugging in what our slope is here and then here, but we can't take a word and plug in a word undefined. It's not like we can plug in the word for the m and write the word undefined. What we have to understand here, the type of line that has a slope that is undefined, let's plot these points real quick. So if I plot this point 2 and 1, 2, 3, 4, 5, that's the first point. If I plot the second point, I'm going to do 2, so negative 1, negative 2, negative 3. If I connect those 2 points, you see how we get a vertical line right here? So vertical lines have slopes that are said to be undefined. So whenever you see that, know that that's a vertical line and our slope will always be considered undefined. The way we write the equation of a vertical line always is x equals some number. So go back to your 2 points here and here. Look at what's highlighted in yellow. Look at your x coordinates. Aren't both of those x coordinates a 2? So that equation for your line is always just x equals a 2. This is the answer to this question. So if you have a vertical line, it's always x equals some number. All right, yeah, Ahmed, go ahead.
I also have a question though.
Yep, go ahead.
Why because the line's irrational number?
Say that one more time now.
Why because it's like an irrational number?
For what, the slope?
The slope.
That's okay. Yeah, you
Don't
could.
it feel like undefined?
No, you can do an irrational number. What you would probably need to do, if we're actually going to graph it, is we would need to round that irrational number so we can actually, get a terminal point that we can count. But you can definitely have an irrational slope. That is legal. Okay.
Okay. Thank you.
Yep. All right. Now the next one, just so we now understand how these are a little bit the same and how they are both different. So let's find the slope of this one. So we want our slope formula. So the x coordinate or the y coordinate in point number 2 is a 5. So you're going to do 5 minus. The y coordinate in point number 1 is also 5. If we do our y's, the x's, the x coordinate in the second point is a -4. Subtract the x coordinate in the first point here would have been the 2. Now notice what we have, 0 over a -6. So now notice how the 0 is on top. So let's see what our calculator tells us that this is going to be. So if I now do 0 on top, divide that by a 6, that's when you're going to get a slope of 0. Okay, so for this one, this gives us a slope of 0. I'm going to do the same thing. We could actually do this with formulas, but this is something you just kind of want to get memorized. Let's plot these points. So the point 2, 5, so 1, 2, and then let's say 5 is up here. So there's that first point, 2, 5. And then plot this point, -4, 5. 4. So -1, -2, -3, -4. If I plot that point, notice how we now get a horizontal line. So this is now horizontal. Notice what is now the same over here. If I look at this point and I look at this point, see how the y coordinates are the same? So the equation of this line you are going to write as y equals 5. And that's how we're going to write the equation of horizontal lines. So keep this straight. My calc kids still screw this up as juniors and seniors. It's the easiest thing that we do, and it's also the hardest. If it's a vertical line, it is always x equals some number, and in this case, it was a 2. If we are looking at a horizontal line, your equation is always y equals some number. Okay, it's actually I always kind of remembered it when I was a kid, and for the people who had me in Math 1, we talked about this. It's the opposite of what you would probably think, because the x-axis isn't the x-axis horizontal. So if I highlight my x-axis right here, that's horizontal, correct? But if I have the x variable, we actually get a vertical line. The y-axis is vertical, but if I have a y equals a number, it actually gives me a horizontal line. So it's kind of the opposite of what your axes would maybe lend you to think would be the case. All right? All right, so now, and that's going to be a big one for what we're going to be doing, is keeping these things straight. So if you remember, right before the end of the semester, we did what we called piecewise functions, and it was multiple equations, multiple graphs, all in one. So that's what this is now saying. So it says connect context, graphical representation. So it says create a story, just a couple of sentences that matches the graph below, and then it says label the X and Y axis as specific as possible in describing what is happening to connect your story to the graph. So now, this is kind of written as if you are actually all together, and we can be creative, and you can make up your own little stories with your partner or two. Obviously, that's not the case. So, let's do this. Anybody got us? So think about what this is saying. Here's our x-axis. Here is our y-axis. Right? So we start right here, and we can make up kind of any story we want. So just go with my story. I actually didn't give this a whole lot of thought beforehand, so spare me for this boring story. But we start at home. And we travel, let's say, so 1, 2, 3, 4, 5. We travel 5 seconds. Actually, let's do minutes. Let's do minutes. So 5 minutes. To the gas station. All right. So what that tells us is if we're traveling 5 minutes here, we're going to label, when I ask you to label your axes, we're going to label the x-axis with a unit of minutes. Let's say you live fairly close to the gas station. So when I'm going to label the y-axis, let's say, because most of you probably don't have, well, it's by 50-50. Some of you may have your license, some of you don't. So let's say we're walking. So we're going to say this is blocks. So we walked in 5 minutes. We walked 5 blocks, and then this took us to the gas station. All right, so that's this spot. Now, think about what that then means, although this is here. Do we travel any more blocks? Be a little more clear here. We arrive at the gas station at this point. Over the next 5 minutes, so let me pull this up. Over the next 5 minutes from here to here, does our distance change at all? Do we travel any more blocks? All right, notice how we're staying at, notice how we are staying 5 blocks away from our home. If this is our home, we traveled 5 blocks. Do our blocks increase at all? Do we get any further from home? No, we stay at 5 blocks the entire time. So what's happening is you're at the gas station for 5 minutes. So that's what we're going to say here. We stay at the gas station for 5 minutes.
And you're looking at shoulders for 5 minutes.
Yeah, you're figuring out which Slurpee to get, right, Ahmed? All those tough decisions.
Yes.
It could be the watermelon, it could be the raspberry. Sometimes they have that blue one. It's tough.
Or the black cherry.
Yeah, the black cherry, yeah. So sometimes that's hard to decide. The Coca-Cola version. So you're deciding. So it takes you a few minutes to get it. You got to get in line. You got to pay. So you spend 5 minutes there. All right. So then notice now what happens. Our third thing that's going to happen. Black. All right. Over the next 5 minutes. So now from this point through here. So for the next 5 minutes, notice how we are now increasing our blocks. So we're traveling again. So what we're going to say is over the next 5 minutes, we travel. And if I go from 5 blocks, that's where I would have been when I'm at the gas station, 5 blocks from home, and I end up at 15 blocks from home. And over the next 5 minutes, we travel 10 blocks. To Cam's house. All right, so this up here, this is Cam's house. All right, because you're meeting up with Cam. Because we spend any time at Cam's house really? Like, is there any time elapsed where we're there? No. So we're really just meeting Cam so that then the last thing we do is we travel. Create some space here. So we travel, this would have been what? 1, 2, 3, 4, 5 more minutes. To school. So you were just meeting Cam. This ends up being school. All right, and it took us 5 more minutes along the x-axis to get there. All right, so that's our cheap little story there. So you stop at the gas station, you're meeting a friend, and then from there you end up traveling to school. All right, so there's my story. So now with that,
I love your story.
thanks, Ahmed. You're a good man, Ahmed. You're good. I don't care what Mr. Kubowitz says about you. I like you a lot. You're a pretty good dude. All right. Yeah. When you're not around, you don't know. You don't want to know what he says. See, he's off camera right now too for that reason.
Don't believe his lies, Ahmed.
Well, I think you're very nice too, Mr. Kluwitz.
Thank you. I appreciate that.
All right. So now number 2. It says if you were to write a function for each part of this graph, how many would you write? It's kind of a giveaway if we just look at number 3 here. But if we look, don't we have 1 line, 2 lines, 3 lines, 4 lines right here? So when we did all those piecewise functions at the beginning, we always had multiple pieces. This time we would need 4 different things. When we travel from home to the gas station, from the gas station, we spend time there, and then we go to the gas station to Cam's, and then from Cam's to school. So what we now want to do, and this is what we last left off with right before the semester, is writing the equation for this function. So we have 4 of them. So now let me go back to my graph. So we have to do this first one. So let me clean this up a little bit so we kind of know what we're looking at. So what we want to do is write the equation for this first line. Okay, get my pen to work. All right, so we just wrote the equation of a line earlier. We now want to write the equation of just that line. Now, notice how this does cross the y-axis here. So do we know the y-intercept of that line? Can we look at that and know where that crosses the y-axis? Yeah, it's at 0, correct? So what we should be able to do here, we should be able to write this one using slope-intercept form. That should be the version that we should be able to go with here. So if I go back to that line, aren't I just going up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1? So basically for every 1 minute I travel, I'm traveling 1 city block. So my slope for that first line is 1. So slot the 1 in for your m. And then if we ask what's your y-intercept, pretty clearly, isn't our y-intercept going right through 0? So you don't necessarily have to put the 1x plus a 0. You can just do x, 1x. But that's the equation of the first line. Remember what your domain is. Your domain is your x values. Now, putting this in terms of time, I hope makes this a little bit easier if you think about domain. How long did it take us to get from here, from home, to the gas station? That's your domain. That's how long it took. Well, didn't that take us 5 minutes? So the way we're going to write that is it took us from 0 to 5. And the way we're going to put this is x has to be less than or equal to 5 or greater than or equal to 0. I would also take, for those who like interval notation, do you remember interval notation, parentheses and brackets, all that good stuff? We reviewed that a little bit. You could say from just 0 to 5. It took us 5 minutes. Okay, either way. All right, so now the next one, and this is where you're going to see this a lot. I promise this is going to be a point of emphasis for us. Notice how the second function is a horizontal line. We want to write the equation of this horizontal line right here. So let's go back to the previous problem. Remember how we write the equation of a horizontal line? Isn't a horizontal line always going to be y equals some number? So go back to your horizontal line in this graph. Not coincidentally, think about what the y coordinate is always in this line. So if I go here, 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 doesn't all of these points have a y coordinate of 5? Okay, so that equation for the second part of the function is just y equals 5. And then that's it. Now, we need our domain. That one started at 5, and it took us, come on, started at 5, and we got to Cam's, or we spent our 5 minutes at the gas station. So from 5 to 10 minutes, we spent time at that gas station. So we put our x in the middle, less than or equal to 10. And then here's something you just want to be a little bit careful of. I don't know if I would take off for this right now as we're learning this, but if I close this equal sign off right here, then the 5 down here, I don't want to put an equal sign underneath that one. So just write this as a less than sign. Okay. All right, third equation. So let's pop up to the third equation here. We now want to write the equation of this line. So we're going to need one of our two forms here. So now here's where we need to know both. The reason I could do slope-intercept form nicely with this first equation, this first line, notice how we know where this crosses the y-axis at, it was 0. But if I try to do this one in slope-intercept form, so don't necessarily write down what I just wrote here, but if I try to do this in slope-intercept form, is there any way for me to know where this line would ultimately cross the y-axis at? Because it's going to be way off of our graph, right? Like if I try to extend this, just happened here. There's going to be no way for us to know where this crosses the y-axis. All right? I can extend it, but if this line continued like this forever, it's going to be way down here at some negative number. So since we don't know our y-intercept, this one is really begging us right now to put this into point slope form. So for this third one, we probably want to go about this with m and then x minus x sub 1 plus a y sub 1. That's how we would have to do that third one. So let's go to that third equation. Let's find the slope of this one first. That should be easy. So if I'm at this point here, and then we go up 2, right 1 each time. So I'm going up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. So I know my slope is 2 over 1. And then I need a point, all right? So in point slope form, we need a point. You have a whole bunch of points. So this is now, and eventually we will probably have you simplify this, but for right now, notice all these different points that lie on this line. So like earlier, I asked Ella which point she wanted to pick. She gave me a point. You really could use any of these 5 points right now. Doesn't matter which of those points you're going to pick. All right, so we're going to call in Ella again. What do you want to pick, Ella? Which one of these points?
5.
All right, so she says 0.5. So we would need to know that that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, comma, 13. So that's the point we're going to use to write the equation in point slope form. So I'm going to have an x coordinate of 14. And then a y coordinate of 13. And then that took us from 10 minutes to 15 minutes. So that's your domain. All right, and then real quick, last one, if we can get this done. Try to write the equation. I'll give you a minute here. Write the equation of that line. How could we write the equation of that fourth and final line? Do we know the y-intercepts? Because if you know the y-intercept, you could do y equals mx plus b. If you don't know what that y-intercept is going to be, then you need to do the whole point slope version. Okay, so see if you can do that real quick. Or just freezing on me here. All right, tell you what, we're up against the time a little bit here. So let's save this one. You can try it, see if you're right, and then we can talk tomorrow if you got it correct. So let's hold off on the homework a little bit. Let's go over this real quick. We'll do that fourth equation. We still got a few things I want to talk about down here. And then we'll give you the homework for tomorrow. Okay? And then we'll check in and see if we understood what this guy was giving us. Then we can actually start the homework a little bit too, because I think some people are going to find this a little bit challenging. All right, so we'll do a problem or two in the homework as well to fill some time and get you started on the right foot tomorrow. All right? Okay, so you were spared again one more night from homework. All right, we'll see you guys. Have a good day. All right, nice job. Take it easy. Zeros.